Hi and welcome to maths class. Today we're going to do two things in this third video on sketching linear graphs. First, I'm going to show you some different examples of using the gradient intercept method, and then we're going to look at vertical and horizontal lines. So first, let's start with the example you've got. Sketch the following graphs using the gradient intercept method. Now, I don't know if you can notice this, but one of the things that's missing here is there's no plus c on the end. Usually when I've got a graph written in y equals mx plus c form, like if it was y equals 2x plus 1, this plus 1 I know is my y-intercept, and that's how I find the y-intercept. That's missing on this equation, and that's because my y-intercept is actually the origin. There is a plus c here. It's like a kind of invisible plus 0. So usually we don't write plus 0 because it's the same as if you don't write it. But the 0 is my y-intercept. So this graph is going to go through the point 0, 0, which is called the origin. It's a special point, it has its own special name. So this is one reason why we need another method. The two-intercept method is not going to work here because this graph has only one intercept. It goes through the origin, and then there's not going to be a second x or y intercept. So we need to find a second point. So let's do it the same way. Whenever you meet these, this is the way you're going to use. You're going to find the gradient. Well, the gradient is 1/3. So that's going to give me a rise of 1 and a run of 3, because rise over run. So from this point, I'm going to go up 1 and across 3. 1, 2, 3. And that brings me here to the point 3, 1. And one of the things that I want you to notice actually is that when my graph goes through the origin, the first point is the rise over the run, 1/3. So I don't even necessarily need to do all this writing down. Okay, let's join our points with a line. Let's see if I can do this. Somewhere here, I reckon. That looks good. All right, that'll do. Okay, 1/3 is not a very steep line. It's quite shallow, as you can see. Okay, we've got another example to do. So go to the next page. Y equals -2x. Same deal. There's no plus c, which means it's plus 0, which means that this graph goes through, goes through the origin. So we'll mark in the point 0, 0. Now you'll notice that I'm noticing that this is a negative gradient, so I'm going to want to draw through there, and that's why I labelled 0, 0 up there. You always need to label it, even when it's the origin and you'd think, oh, everyone knows what that point is. You've got to label it, okay? Because you're pointing out that, you know, I mean, it could be the point 0.1 and it would look very much like the origin. When you label it, you make it clear this is exactly the point it is. Okay, and then my gradient is -2, which I can rewrite as -2/1. So my rise is going to be -2. I'm going down. And my run is going to be 1. So I'm going to go down 2, 1, 2, and across 1. And that will bring me to the point 1, -2. And as I said to you, that's the same as rise over run. So I could have, from here, straight away decided that my new point was going to be 1, -2. But that only works for graphs of this form where there's no plus c. It won't work for any other graph. All right, let's join it all with a line. And once I've done that, I'm going to point out a couple of things for you about this graph. Okay, that'll do. Put some arrows on it. Because I know that you're drawing all your graphs by hand. So I want to point out a couple of things. And I'm going to use a different colour to point it out. My axes are labelled with x and y. I have a nice clear scale marked on my graph. And both of my points are labelled with coordinate pairs. So label axes with X and Y. Oops. Label points with coordinate pairs. Okay, and make sure your scale is clear. Okay, all right, so that's this particular kind of graph that has y equals mx with no plus c. So now we're going to look at some vertical and horizontal lines. So let's start with this first graph of y equals 3. Now, this is a weird equation because there's no x in it. And the reason for that is it doesn't matter what x is, y is always 3. So when x is 4, y is 3. When x is -2, y is 3. When x is 0, y is 3. Regardless of what x is, y is always 3. So let's think about that. This here is the point, oh, I'm still in red. This is the point 0, 3, y is 3 there. Another point that I said was 4, 3. Y is also 3 there. Over here is the point -1, 3. Y is also 3 there. Just here we've got -2.5, 3. Here we've got -5, 3. Just there is the point 0.1, 3. And here is, oops. Here is 3, 3. Here is 3.5, 3. Are you starting to get the picture? This graph is going to make a horizontal line. Oops, keep going. Okay, so all we need to do when we have y equals anything is we label the y-intercept. Oh, come on, not with a line. Label the y-intercept as 0, 3, and then draw a horizontal line through it as quickly as you like. So let's practice that with y equals -2. I'm going to label the y-intercept as 0, -2. So that's just here, 0, -2. And then I take my ruler and I draw a straight line all the way through it. Put some arrows on the end. And pretty much I'm done. If we want to be really perfect, let's label a second point, because really to define a straight line you always need 2 points, and this shows that this really is an exactly horizontal line. Okay, now we're going to look at vertical lines, and you guessed it, I'm hoping you guessed it, these have the form x equals something. Now the one we're starting with is x equals 2.5. In this equation, y doesn't matter. Doesn't matter what y is, x is 2.5. Here is the point 0, 2.50, where x is 2.5 and y is 0. Right here we've got x is 2.5 and y is 2. Down here we've got x is 2.5 and y is -3. And so on and so on and so on. This is going to be a vertical line. I've lost it. Come on, little mouse. There we go. Oh, seriously? That'll have to do. Okay, so that is my vertical line. It goes through the point x equals 2.5, which is the equation. It goes through the point x is 2.5 and y is 0, and I always label that point. So let's practice it with x equals -1. I find the point x equals -1 and I mark it in -1, 0. Then I simply draw a vertical line straight through. Put some arrows on the end to show that the line doesn't end just because our page ends. A line is infinitely long, and that's the end. So here's my summary. Sketching vertical and horizontal lines. Equation of the form y equals c are always going to be horizontal lines. And equations of the form x equals a are always going to be vertical lines. So that's when you've only got either x or y in the equation, whereas with y equals mx plus c, we've got both of them in the equation. Here we've only got x or only y. And remember to label the intercept. And if you really want to be perfect, label one other point. And finally, remember to put arrows on your line. Okay, that's everything you need to know about sketching linear graphs.